Let mod m denote the determinant of a square matrix M. If there is a square matrix M, then mod of M will have the value of determinant of that square matrix. And this mapping of a function which is G is given is like that. Here domain is 0 to pi by 2, and codomain is all real numbers. So this function is defined like this, and after that f theta is used here. So f theta is further defined like this. Let px be an quadratic polynomial whose roots are maximum value and minimum values of function g theta. See, g theta will have some maximum value and have some minimum value, and minimum value are roots of quadratic polynomial px. Okay, so and we have one value is also given, p2 is 2 minus root 2. So we have to check whether which option is correct here. Firstly, we will go through the f theta, since f theta is used in g theta. So see, we can see that f theta have two determinants. First is this and second is this. So if I simplify this determinant, firstly this determinant, so it will be like that: 1 2 1 plus sine square theta, half is all outside, and then minus sine theta will be minus sine theta plus sine theta, that will be 0, plus 1 uh, sine square theta plus 1 plus 1. Okay, we will have here 1 plus sine square theta. So we have calculated the value of this determinant, and now we have to see what this determinant gives us. So you can see that firstly this sine pi minus cos pi by 2 and tan pi will have value 0. So main diagonal is 0 of this determinant. So how can I write this determinant further? We can write it as 0 cos theta plus pi by 4 plus pi by 4. You must be thinking that why I'm simply expanding this determinant, not thinking of a short approach. See, in this determinant we have cos theta plus pi by 4 and we have sin theta minus pi by 4. If you will evaluate by using the formula of sin a plus b and sin a minus b here and cos a plus b here, then you will see that these both terms are same. After putting the value of sin pi by 4 cos pi by 4 respectively, there will have a same expression. So you can see that let me highlight this. You may see that these two terms are going to be equal. Again, if you will go through this term, this tan theta minus pi by 4 and cot theta plus pi by 4, they are also going to be similar. How they will be similar? They will be similar like this. If you convert this tan, if you will convert this tan into sine upon cos and this cot into cos upon sine, then after further expanding using the formula of cos a plus b sin a minus b and cos a plus b cos a minus b sin a minus b, you will have these two both terms as an equal value will be same. And again, so and we have log e to the 4 log 4 pi 4y pi here, log pi by 4. And if I uh, there is a difference of only minus sign here, so these both terms are also same. So it seems to be going to simplify on expanding this determinant. So that's why I'm just simply expanding this determinant. Okay, so cos theta plus pi by 4, and we will have here is a log 4 by pi into cot theta plus pi by 4. Okay, since this will be negative here, and then after that tan theta minus pi by 4, and here there will be sin theta minus pi by 4 into log pi by 4 to the base e. Okay, so if I change this argument here, so the minus sign is going to vanish here. It will be pi by 4 here. Okay, so what here finally we have, if I take here log pi by 4 as common, we will have here is, if I break cot into cos upon sine, so finally we will have cos square theta plus pi by 4 by sine theta plus pi by 4, plus here there will be sine square theta minus pi by 4 cos theta minus pi by 4. I have changed tan theta is in sine theta upon cos theta as well. I have changed tan theta into sine theta upon cos theta. So there is one mistake here. Since on expanding with respect to cos theta plus pi by 4, we will have negative with the coefficient, and further we will have negative on taking its cofactor. Fine. So there will be two negatives and they will be positive after when I have here changed lastly I have changed this argument of log. So this one second, on expanding this cos theta plus pi by 4, I have we will have coefficient here as negative, and on cancelling this t, then we have one negative with this with coefficient, and another negative with on taking its cofactor. So the negative will be vanished, and after that I have changed here argument lastly, so there will be one more negative. So we will have here negative. Okay, so on negative, so further we will have here negative. So let firstly see here these two terms, this and this. If I name these two terms are same, exactly same, leaving sign, these two terms are exactly same. How? You can simply see that sine cos theta minus pi by 4 will be cos theta cos pi by 4 plus sine theta sine pi by 4. So it will be 1 by root 2 cos theta plus 1 by root 2 sine theta. Similarly, this term this denominator, if I talk about denominator on both sides, see this will be cos theta cos pi by 4, sin theta sin plus sin theta sin pi by 4, and it will be 1 by root 2 cos theta plus 1 by root 2 sin theta. Similarly, this will also sin theta cos pi by 4 plus cos theta sin pi by 4, and it will again 1 by root 2 cos theta plus 1 by root 2 sin theta, because sin pi by 4 and cos pi by 4 have same value. Fine. Similarly, cos theta plus pi by 4 will have same value as sin theta minus pi by 4. I have proved, because here there will be minus in between, sin theta cos pi by 4 minus cos theta sin pi by 4. Similarly, there will also be cos theta sin cos pi by 4 minus sin theta sin pi by 4. So you can see that there is uh, 1 by root 2 cos theta minus 1 by root 2 sin theta. There is also 1 by root 2 minus 1 by root 2 sin theta. You can simply take minus sign common, because there is whole square, so nothing matter, it doesn't matter which have negative sign, cos theta or sin theta. Fine. So these two terms have same value, so they will be cancelled. Okay, so cancelled, if then it will have value 0. So this determinant will have value 0. Fine. So finally f theta we have evaluated here. F theta was 1 plus sine square theta. Okay, sorry. Now since I have here g theta is further taken in the terms of f theta, which is f theta minus 1 plus f of pi by 2 minus theta minus 1 minus 1. Okay, so let me substitute this f theta here. So here will be sine theta. Since sine theta is between 0 to pi by 2, you can see here mapping of the function. This is mapping of the function which is given as 0 to pi by 2. Here sine will be positive, so no need of putting mod there. Mod is not needed here since sine theta is positive. Fine. Sine pi by 2 minus theta will be cos theta, 1 plus cos square theta, that will be cos theta. Fine. So finally we have function g theta is equal to sine theta plus cos theta. Fine. And we have value g theta as 0 to pi by 2. So if I modify it as multiplying by 1 by root 2 and 1 by and dividing by 1 by multiplying by root 2 and dividing by root 2, here I will have here root 2, and it will become as sine theta plus pi by 4. Okay, I draw the graph of this function. It will like this. Since at minus pi by 4 sine is going to have 0 value, so it will shift towards left, and the graph is going to look as this, minus pi by 4, like this. Fine. Because f and I have g theta is 0 to pi by 2. This g theta is 0 to pi by 2. So at 0 g theta, it will have, so it will have minimum, if theta is from 0 to pi by 2, then we will have 0 here and pi by 2 somewhere here. Okay, so pi by 2 at 0 it will have 0 minimum value, and at pi by 2 it will have maximum value. And this 0 and pi by 2, are the argument of sine, not sine theta, not that theta value. I'm not talking about that theta, because this graph is drawn like this: sine theta plus pi by 4, and here it is theta. Okay, because at pi by 2 we will have maximum value of sine, so at theta is equal to pi by 4 we will have maximum value of sine. Fine. So at theta is equal to 0 we will have minimum value, since this is minimum, and at theta is equal to pi by 4 we will have maximum value. So theta is equal to 0 will be have minimum value, which will be 1, and theta is equal to pi by 4 we will have maximum value, which will be 1 root 2. So for px we have two roots, 1 root 2. Okay, so you may heard about the quadratic equations. If you have two roots known, then how to frame a quadratic equation using that two roots. So it is like this, that you will write this: px is equal to x square minus sx plus p. Okay, so s here is sum of the roots. S will be sum of the roots, and p will be product of the roots, root 2. So x square minus 1 plus root 2 x plus root 2. Okay, you can further verify by putting the value of this p2. You will find here 2 minus root 2 will come, so I'm not getting into that. I have to verify p3 plus root 2 by 4 is negative, means there are some values of x, whether there we have positive or negative value. So if I talk about px, which is x square minus 1 plus root 2 x plus root, so if the equation is like this, then the graph is going to like this of this quadratic equation. It will be parabola, and it will look like something like this. Since it have two roots, since here a is positive, or you can also say like that, if you will frame this polynomial this polynomial as a perfect square, it is going to frame like this something, x minus some x dash of whole square. If you will frame this as a perfect square, and there will be positive sign. Okay, there are two roots, which is one is 1 and another is root 2. So we can see that before 1 the value is positive, before the x is before the value of x at is 1, the value of px is positive, and here there is negative, and again there is positive. Okay, so we will check similarly. So there will be 3 plus 1.414, so it will be 4.414, and divided by 4, then it will be 1.1. It will we can say that this value is greater than 1. So on greater than 1, the value of polynomial will be negative, this domain. Okay, so our A option is correct here. So on, let's see the B option. 3 plus 3 into 2 into root 2, what it will be? 4.2 plus 1, 5.2. It will be, again it will be greater than 1. This quantity again will be greater than 1, but we have given it as positive, but it is not positive, it will be negative. You can see that this domain is negative. So C part, on taking 5 into 1.4, so it will be 7 minus 1 by 4, 7 minus 1, 6. It will be something like that, 1 point, 1 point something, it will be greater than 1, but we must see, is it less than 1.414? So you will, if you will calculate this inner value, you will have their value as 1.51. Okay, so 1 point, it is greater than root 2, so it is, if it is greater than root 2, then the value is going to lie here and the value here will be positive. So here similarly you will check that these all values will be less than root 2 but greater than 1. Similarly this option 5 minus 1 uh, less than 1, it is less than 1, so at less than 1 we have positive value, and here it is given negative, so this option is also incorrect. So we have correct option as A and C. See, there are multiple concepts are used, so it is good question. So thank you and have a nice day.